Ever wondered how safe nuclear energy truly is? And what is this burn-up credit we keep hearing about in the nuclear field? Well, let's dive right in. Nuclear safety is paramount and encompasses a broad spectrum of practices, procedures, and technologies. One critical component within this landscape is burn-up credit. Now, you might be wondering, what exactly is burn-up credit? It's a concept that allows us to account for the reduced reactivity of spent nuclear fuel due to burn-up. Essentially, it's a method to quantify how much energy has been extracted from nuclear fuel and how this affects its reactivity. So why is this important? Well, understanding and accurately calculating burn-up credit contributes to safer, more efficient nuclear fuel handling. It's a cornerstone of criticality safety analyses for pressurized water reactor, or PWR, spent fuel. Now, let's rewind a bit to the year 2012. This was when the US Nuclear Regulatory Commission released Revision 3 of Interim Staff Guidance 8, also known as ISG 8. This document was a game changer. It revolutionized the approach to criticality safety analyses for PWR spent fuel, placing burn-up credit at the heart of the process. However, implementing burn-up credit is no simple task. It demands predicting complex nuclide concentrations, considering axial and horizontal burn-up variations, and accounting for uncertainties. It's a complex concept that requires accurate predictions. But why go to all this trouble? Well, the answer is simple: safety. Ensuring the safe operation of nuclear facilities is a top priority. And burn-up credit plays a key role in achieving this. With accurate burn-up credit calculations, we can better manage spent nuclear fuel, reducing the risk of criticality accidents. So, there you have it. From the importance of nuclear safety to the intricacies of burn-up credit and its role in the ISG 8 regulatory guidance. Burn-up credit is a complex concept that requires accurate predictions, but it's a crucial part of nuclear safety. And as we continue to advance in this field, we move closer to a future where nuclear energy is not just powerful, but inherently safe. Implementing burn-up credit may sound straightforward, but in reality, it's a task that demands precision and expertise. You see, the very concept of burn-up credit hinges on the ability to accurately account for the reduced reactivity in spent nuclear fuel. This reduced reactivity, or burn-up, results from the gradual consumption of fissile materials during operation. But predicting these complex nuclide concentrations is no simple matter. It's like trying to forecast the weather, but instead of rain or sunshine, we're dealing with the minutiae of atomic particles. Even the slightest miscalculation can have significant implications, so there's no room for error. And it doesn't stop there. Burn-up isn't uniform. It varies both axially along the fuel rod and radially across the fuel assembly. So you can't just take a one-size-fits-all approach. Each section of the fuel assembly burns up at a different rate, and this must be taken into account when calculating burn-up credit. On top of that, there's the issue of uncertainties. These can arise from a whole host of factors, like measurement errors, manufacturing variations, or even changes in operating conditions. And these uncertainties aren't just inconveniences, they're critical factors that must be quantified and incorporated into the safety analysis. Then there's the question of compliance. Any system used to implement burn-up credit must adhere to stringent regulatory standards, ensuring that safety remains paramount at all times. So it's not just about getting the job done, it's about getting it done right. In short, implementing burn-up credit is a delicate dance. A balancing act between accuracy, complexity, and regulatory compliance. It's a task that requires a deep understanding of nuclear physics, coupled with the ability to navigate the labyrinth of regulatory guidance. These challenges require an advanced system to tackle, and that's where the Starbuck system comes in. This innovative system serves as a beacon of hope, promising a more efficient and accurate approach to implementing burn-up credit. But more on that in the next scene. Until then, remember, in the world of nuclear safety, every detail matters. Meet Starbucks, the game changer in the world of burn-up credit. Born from the necessity to simplify and streamline the complex process of implementing burn-up credit, Starbucks is the cutting-edge system that's shifting the paradigm. Starbucks, an acronym for Standardized Analysis of Reactivity for Burn-Up Credit using SCALE, is a revolutionary tool developed as part of the Scale 5 suite. It's not just a fancy name, it's a powerful system that automates the generation of spatially varying nuclide compositions. But that's not all. Starbucks also conducts three-dimensional Monte Carlo analyses of the system, handling the intricate calculations with ease and precision. Imagine having the ability to predict complex nuclide concentrations, to account for axial and horizontal burnup variations, to accommodate uncertainties, all with just a few clicks. That's the power of Starbucks. It's like having an expert nuclear engineer at your fingertips, guiding you through the labyrinth of criticality safety analyses. But Starbucks is more than a tool for analysts. It's also a boon for reviewers. It provides a standardized approach to safety assessments, ensuring consistency and compliance with regulatory standards. No more worries about discrepancies or misinterpretations. Starbucks takes care of it all, making the process seamless and efficient. With Starbucks, the possibilities are vast. From single criticality calculations to iterative burnup loading curve analyses, this system streamlines the process, adjusting initial fuel enrichments and ensuring convergence to subcritical limits. And if a solution isn't feasible, Starbucks will flag it, preventing potential errors and saving valuable time. Yes, Starbucks might seem like a dream, but it's here, it's real, and it's transforming the way we approach burnup credit. With Starbucks, we're not just tackling the challenges of today, we're paving the way for a safer, more efficient future in nuclear energy. Starbucks is designed to make criticality safety assessments seamless and efficient. So welcome to the world of Starbucks, where the complexities of burnup credit become manageable, where innovation meets regulation, and where the future of nuclear safety is being shaped, one calculation at a time. Starbucks is robust and flexible, but it's not without its limitations. This system, designed for efficiency and adaptability, offers a wide range of capabilities. It's equipped to handle diverse nuclear configurations. Whether dealing with pressurized water reactors or boiling water reactors, Starbucks can adapt. It streamlines the process of burnup credit analysis, ensuring compliance with stringent regulatory standards. The system automates the generation of spatially varying nuclide compositions, reducing the risk of human error and increasing efficiency. It also conducts three-dimensional Monte Carlo analyses, providing a comprehensive view of the system. This feature allows analysts to assess the safety of various nuclear configurations with a level of detail and precision that was previously unattainable. But like any system, Starbucks has its limitations. It's a complex program requiring skilled operators. While its automation capabilities are remarkable, they cannot replace the expertise of a trained nuclear analyst. It's also reliant on the quality of the input data. Garbage in, garbage out, as the saying goes. Inaccurate or incomplete data can lead to misleading results, potentially compromising safety. Moreover, while Starbucks has been optimized for efficiency, it's still a computationally intensive process. The system demands significant computational resources, particularly for larger, more complex nuclear configurations. This can be a challenge in environments with limited computing power. Lastly, while Starbucks is an advanced tool, it's not a silver bullet. It doesn't entirely eliminate the need for other safety measures. Burnup credit analysis is just one piece of the nuclear safety puzzle. It should be used in conjunction with other safety assessments and procedures to ensure a comprehensive approach to nuclear safety. Despite these limitations, Starbucks remains an important tool in the nuclear industry. It's a cornerstone of modern burnup credit analysis, offering a level of precision and efficiency that was previously out of reach. It's a testament to the power of innovation in the pursuit of nuclear safety. Despite its limitations, Starbucks remains a cornerstone of modern burnup credit analysis. As we stand on the precipice of a new era in nuclear safety, Starbucks is leading the way. This innovative system, marrying the practicality of regulatory standards with the ingenuity of technological advancements, has become the vanguard of nuclear safety procedures. Starbucks represents a leap forward in burnup credit analysis. Its unique ability to automate complex calculations and conduct in-depth Monte Carlo analyses has revolutionized the way we approach nuclear safety. But the true power of Starbucks lies in its adaptability and its integration with existing code modules. The system works seamlessly with well-established code modules like ARP, the Automatic Rapid Processing Code, and Origin, the Oak Ridge Isotope Generation and Depletion Code. These modules, each highly regarded in their own right, contribute to the robustness and computational efficiency of Starbucks. ARP, known for its ability to accurately predict nuclide concentrations, aids Starbucks in honing its predictions. It helps ensure that the system's calculations are precise, reliable, and in line with the high standards demanded by nuclear safety. Meanwhile, Origin contributes to the system's capability to model nuclear reactions and radioactive decay. It provides Starbucks with the tools necessary to simulate and analyze nuclear fuel burnup, further enhancing its accuracy and reliability. Together, these modules allow Starbucks to provide a comprehensive and effective solution for burnup credit analysis. They facilitate the system's adaptability, enabling it to cater to diverse nuclear configurations and evolving safety standards. As we look to the future, Starbucks continues to evolve, adapting to new challenges and rising to meet the ever-growing demands of nuclear safety. Its role in advancing nuclear safety procedures is evident, and its potential is boundless. In the intricate dance of nuclear safety, Starbucks is a shining star, illuminating the path towards a safer, more sustainable future. Its success is testament to the power of innovation when harnessed for the greater good. And it reminds us that every advancement brings us one step closer to a world where nuclear energy is not just powerful, but inherently safe.